Okay, solve each equation. So for the first equation, first I'm going to distribute this negative 4. So we get 3x plus 2 equals 10 minus 4x plus 4. Then I'm going to combine my like terms on each side. Here I don't have any, so it'll stay the same, 3x plus 2. Here I have 10 and 4, so it'll be 14 minus 4x. Add 4x to both sides, and we get 7x plus 2 equals 14. Then we'll subtract 2 from both sides. 7x equals 12, divide by 7 on both sides, and we get x equals 12/7. I think some of these problems are similar to homework 16 for Unit 5, but that's okay, we can practice them again. Again, we'll distribute here. So we get 4x minus 4 equals negative 6x, or sorry, minus 6x, let's see, minus 10 equals negative 3x plus 1. 4x and negative 6x makes negative 2x. Negative 4 and negative 10 makes negative 14 equals negative 3x plus 1. We can add 14 to both sides, so we get negative 2x equals negative 3x plus 15, and then add 3x to both sides, and we get x equals 15. Here we have to complete these generic rectangles, and so we know 2x times 3x would give us 6x squared. 1 times 5 would give us 5. 5 times 3x would be 15x, and 2x times 1 would be 2x. X times 2x is 2x squared. 2x times 6 would make 12x. 6 times 3 would give us 18. And x times 3 would be 3x. X times x would give us x squared. 4 times x would make 4x. 3 times x would make 3x. And 3 times 4 would make 12. Find the equation of the line with a slope of negative 4/3 that passes through the point 12, negative 4. So we want the slope to be negative 4/3, and we don't know the y-intercept. So we can plug in x and y to this line to solve for b. So we plug in negative 4 for y equals negative 4/3 times 12 for x plus b. 4/3 just means 12 divided by 3, which is 4, times negative 4 is negative 16. Then we add 16 to both sides, and we get 12 equals b. So the equation of our line is y equals negative 4/3 x plus 12. So graph this parabola. So first I'm going to draw my grid. Let's see, I know it's going to be facing up. So I'll put the x-axis a little bit lower. Right here, I know that if I use the zero product property, I know that my x-intercepts are going to be 2 and 4. So then I know that the line of symmetry is x equals 3. And I can plug that in to find the vertex. So y equals 2 times 3 minus 2 times 3 minus 4, which is 2 times 1 times negative 1, which is negative 2. So the vertex is at 3, negative 2. The x-intercepts are at 4, 0, and 2, 0. And then the y-intercept, I can find that by plugging in 0 for x. So I get 2 times negative 2 times negative 4, which is 2 times 8, which is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I can put the symmetry point over here. So here's my parabola. Solve the system of equations below using any method. So I noticed that I can't use elimination right away because the variables aren't lined up. I can't use substitution right away because there's no variable that is by itself on one side of the equation. So I'm going to line up my variables so that I can use elimination. So I'll subtract u from both sides. So we get 5u plus 6v equals 2, and then negative u plus 2v equals negative 10. Then I'm going to multiply this equation times negative 3 so that the v's will cancel out. So we get 5u plus 6v equals 2, and then negative 3 times negative u is just 3u. Negative 3 times negative 2v is negative 6v, and negative 3 times 10 is 30. So now if I add these equations together, the v's will cancel out. We're left with 8u equals 32, and we get u equals 4. Then we need to plug that in to find v. So we know 2v equals 4 minus 10, so 2v equals negative 6. Divide both sides by 2, and we get v equals negative 3.